Hi everyone. In this tutorial, we are going to see the layering approach in the computer networks. That what is the layering approach and why such thing is required to solve a problem. So consider a situation that at the manufacturing site, the space shuttle and its rockets are being made, and you have to transfer you have to transfer the space shuttle from its manufacturing place to the launching pad. Consider the distance between them is 500 km, and the route they follow is also very complex. So if we want to transfer the space shuttle and the rockets from its manufacturing site to the launching pad, it is very difficult. So what we can do is we will divide this problem into smaller parts. We will divide this task of transferring the space shuttle to the launch manufacturing place to launching pad into small tasks so that we can achieve the goal. So what we can do is we will deassemble the space shuttle into small parts, which are small enough that can be carried by the trucks or vehicle, right? So we will what we can do is we will deassemble the space shuttle into small parts, and we will put that parts into truck, and the truck will follow different route and they will be delivered. Now you have to see the order of the trucks at the sending site. So as you can see the order of the truck here, and when they will follow the path and when the all the parts will be delivered, the order of the truck will be changed. Why they will be changed? Because uh, there is a possibility that the some truck may follow different route, and there is a possibility that some truck may face traffic, and some may don't face traffic. Okay, so they will be follow a different route and they will be delivered at different rate. Okay, and as you can see that the order is changed. Now what will happen at the launching pad, that all the parts will be again assembled together, and then after they again it will be tested and the whole space shuttle and rockets will be sent to the space. So what I'm trying to say is this task, okay, the transferring this massive space shuttle and rockets is very difficult. Okay, so this problem to solve this problem, what we did was we divided this space shuttle into smaller parts. Okay, we divide the whole problem into smaller tasks so that we can solve the problem. Okay, so this thing is known as a layering approach. So in the layering approach, we will divide the whole problem into smaller problems, and we will try to solve these smaller problems, and eventually the whole problem will be solved. Okay, so what we are doing at the sending side, what we are doing at the manufacturing side is that first we will do the testing of the space shuttle. After the testing is being done, we will do the de-assembly, and after the de-assembly is done, we will send via the trucks. At the receiver side, same thing will happen. The all the spare parts will be received. Uh, then after assembly will be done, and then after testing will be done, and the space shuttle will be launched, right? So this one task, we can consider this one task as one layer. Like at the sending side, there is a layer of testing. In the testing they will follow some procedure and they will follow some protocols, and after the testing is being done they will follow the de-assembly. So the D-assembly, we can also consider this as a layer. In the D-assembly layer, what they will do, they will deassemble the whole space shuttle and rockets into small parts. They will mark the number on them. so that it will be easy when it will be received at the launching site, and then after it will be sent. Okay, so sent, what happened in the sending layer, that the truck will follow different route, and they will try their maximum to deliver their spare parts, right? So using this layering approach, you can understand that it become easy to solve a problem, right? So what is the advantage of layering approach? With a layer approach, the problem and or task is divided into smaller parts so that we can solve the problem very easily. And it eases the maintenance, and updating of the system becomes very easy. Okay, and in each layer, they will follow some protocols. So protocols define format, order of message sent and received among network entities, and action taken on message transmission and receiving. We are going to see protocol in detail. Now, the OSI layer. Now, as we discussed in the layering concept, that to do a task, to perform a task, if we divide the task into smaller tasks and we assign one smaller task to one layer, then the solving of the problem becomes very easy. Okay, so if you want to connect one computer to another, okay, over the internet, then you have to follow OSI layer. Okay, now you are using your laptop and mobiles, and with just a click you can send data from the one PC to another. With just a tap of with just a tap you can send message from your phone to your friend, okay, over the internet. So it becomes it seems very easy that you are just pressing a button and the message are being sent, but in the background it is very there are many tasks are being done. Okay, there are many things are happening in the background that we don't know. So we, as an engineer, we supposed to know that what happens when you press a key, and what happens that when you are connecting to the internet, when you are browsing the internet, what are the processes that are happening in the background, is right. So you're supposed to know that. So when if you want to connect your PC, if you want to connect your data, if you want to connect your device from the one, if you want to connect now, the OSI layer. What is OSI layer? That suppose you want to connect to computers over the internet, then you should follow this layer, which is known as the OSI layer. Okay, so we all use internet today. We can send message with just a click or with just a tap, but there are lots of process which are going in the background that we are not aware of. So if you want to send data from the one PC to another, from one device to another, that data, to send the data, it should follow some protocols. Okay, so as you can see that this OSI layer has 7 layers, and the position of these layers are fixed. The first is the application layer, the presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer. So, and this position of the layer is fixed, so you cannot change any layer. Okay, and this OSI layer was developed by the International Organization of Standard, and OSI stand for Open System Interconnection. So when you want to communicate between two devices, this is standard procedure, okay, that should be followed by each and every device that wants to communicate. Okay, and the one layer, okay, for example application layer. So the application layer will have some protocols. The presentation layer has its own protocols. Each and every layer is defined by some particular task. We will see that physical layer has some particular task, the data link layer has some task, the network layer has some task, the transport layer has some task. So each and every layer has some protocols and it has particular task. Okay. Uh, Now, as you can see, um, okay, this computer, okay, wants to send data. For example, this computer wants to send message hi. So when it will send message, when the computer will send message, the message will follow all the layers. Okay, let's try to understand. This is the OSI layer which we just discussed. That it has the seven layer. It has seven layers: application layer, a presentation layer, the session layer, transport layer, network layer, data link layer, and the physical layer. It has seven layers. Each layer has a particular task. Okay, uh, and each layer has some protocols. What is protocol? Protocol is a set of rules. So now in this example, suppose that you want to send hi message to your friend. So this message will follow all the layers. Okay, so when the hi message is passed to the application layer, when the hi message is passed to application layer, so in the application layer some header will be added. So D7 is our message which is hi, and when the message is passed to the application layer some header will be added. Now what is the information stored in header? So the information in the header is added by protocols in the layer, and this information in the header is only understood by that particular layer. So what I'm trying to say is the data which is added, the information which is added in the H7 cannot be understood by the presentation layer. Okay, now in the application layer the data will be added some header. So D7 and H7 will become the whole data and it will be passed to the presentation layer. So now when it is passed to presentation layer, D7 and H7 together known as D6. Okay, so the D6 will be again this D7 and H7 in the presentation layer. H6 header will be added. Again in the H6 header, there should be some information according to protocol used by in the presentation layer. Okay, and the information which is used in H6 is only understood by the presentation layer. No other layer can understand the information in the H6. Again in the presentation layer, D7 and H6 are combined, and when it is passed to the session layer will add its own header. Okay, then after it will pass to the transport layer. In the transport layer, D5 and H5 in the session layer together known as D4, and the H4 will be added. Again it will be passed to the network layer. Again the header is added. It will be passed to the data link layer. The header and tailor will be added. It will pass to the physical layer. Again the header will be added. So when you okay, in when you are using let's say in the browser you are just typing hi, and when you are pressing the enter button, this message will follow all the layers, okay, to reach your friend's computer. Okay, now in each layer, in each layer, this particular data is called with a particular notation. Okay. Mm, right. Now, in the application, as you can see in the application layer, the D7 and H7 are combined. So this D7 and H7 together called data. They are together called they are together called data. The D6 and H6 combined together called data. The D5 and H5 together called data. Okay, and this thing is called protocol data unit, PDU. Okay, so when I say when I ask you that what is the PDU for application layer, so the answer should be data. What is the PDU for presentation layer? It is again data, and same for the session layer, right? Okay, so now as you can see that for the transport layer, a PDU is segment. So the D4 and H4 together are called segment. In the network layer, D3 and H3 together are called packet. So this whole thing, right? This whole thing is called packet. This whole thing is called segment. Okay, this whole thing together is called what? Data, right? So as you can see that in the data link layer, T2, D2 and H2 are called frame, and in the physical layer they are called bits, right? Now one more thing, that as you can see that in session layer, uh, this is data, right? This is data in session layer, and this whole data, it will be added here. This whole data, it will be added here, and in the transport layer, H4 header will be added, and this whole thing is known as segment. Okay, so data is encapsulated in the segment. Again, now this segment is again sent to the network layer. In the network layer, this segment are stored here, and some H3 header will be added by the network layer. Okay, so the segment is encapsulated in the packets, because this whole segment, it will be stored here, and the network layer will add some header. So this thing is known as packets. Okay, and this process is known as the encapsulation, right? So what is encapsulation? The segment is passed to the network layer, and the network layer will add header to the segment, and the segment and header together are called packet. Same in the session layer, the data is passed to the transport layer. The transport layer will add its own header H4 in the data, and this process is known as the encapsulation. Okay, now we are going to see the working of layer using animation. Okay, so that you can understand a little better. Okay, so now suppose that Mm, let me change the color. Okay. Now suppose that this is your PC, okay, and you want to send data to this PC. Okay. So when you are typing message, and when you send the message, your message will pass all the layers. So it will pass first application layer, then after the presentation layer, session, transport, network, data link, and the physical layer. Okay, and it will pass through all the network. So when you are sending the flow of the data when you're sending any message, the flow of the data is from the application layer to the physical layer. Okay, top to down, from the layer 7 to layer 1. Now at the same time, your friend is receiving data, so the flow of the data is from the physical layer to the application layer. So the flow of the data is reverse direction. Okay, so when you're sending data, the flow of the data is from the application to physical layer. When you're receiving the data, the flow of the data is physical layer to application layer. And you know that, like when you're sending message, the application layer will add some header and it will pass to the presentation layer. It will add some header, it will pass to the presentation session layer. Okay, then data will be passed to the transport layer. In transport layer, uh, some header will be added to data and it will called segment. The segment will pass to the network layer. In the network layer, segment, some header will be added to the segment and it will call what? Packets, right? Then after packet will be passed to the data link layer. In the data link layer, header will be added and it will call as frames, right? And it will pass to the, so each and every layer some information will be added and it will become okay, it will become its own packet and it will be passed to the next layer. Okay, so let's run this thing. Let me clear this. Okay, so as you can see that the segment is transfer packet is converted into frame, and then in the physical layer bits will be follow. At the receiver side, the process